Good morning. Good morning. Good. So they had their coffee. All right. So I have actually a lot of information to share today. So and I have 40 minutes. You're going to see a lot of slides, lots of tips and tricks. Don't worry about the syntax. Don't worry about the content that I say because I will share all of them. Just give your attention to me. Listen to me and listen to slides. You will get all the samples, examples, everything that I share. So no worry about that. So just tell me if, so double check. I'm actually loud already. I don't think, but anyway, is it better? Yeah. Good? Thank you. All right, so let's, this is loud. I told you I'm loud. Let's go. Let's now talk about it then. Probably, first thing first, you're all Flutter developers, right? Let's double check. If you don't raise your hand, that means you're not Flutter developer. But why are you here? Okay, so you probably have built, I assume because you're Flutter developers, some apps. And I don't know if you've ever seen these type of messages from other people or maybe in your company that you build app that, hey, my Flutter app is crashing, or there is an app that I built is crashing. I don't know why, but I know it's about memory and so on and so forth. It's actually quite a common problem. Some of the issues that I mentioned today, I mistakenly also have written that way without me noticing that I am exposing my app to a memory leak. So unfortunately, you only notice it when your app is crashing. So, but luckily today, I can show you a few things, a few tools that you will see. It's not only about, from now on, hopefully after this talk, is not just about you make this mistake, but there are tools also available to help you, even when you are writing unit tests or things like that, to make sure you are preventing these type of issues. A quick introduction. So already many of you know me. So my name is Majid, coming from Norway, all the way here, 24 hours flight. It was very nice. It's still jet lag, but you know me probably because of my book. I have written a book about Flutter as well. Some of you reached out to me and say you've read the book. So, and I'm also pretty active in Flutter community. At the moment, I'm working at Microsoft, nothing to do with Flutter. I do something else, but in my spare time, I do a lot of Flutter still. So that's why I am here. And what are we going to talk today? We had a brief introduction to the Dart garbage collection and Dart VM yesterday a bit, but I'm going to actually open it up for you, like show how really this is working and why and where this matters for us as Flutter developers, different type of leaks that may happen, and some detection tools, as well as best practices that I will mention to you. Let me just have a disclaimer first. When we're talking about memory leaks in Flutter, essentially there are different layers. So we're talking today particularly on the high level Dart layer, because we're talking about Dart garbage collection. However, there might be memory leaks from the plugins that you use and so on and so forth in the native code and so on. We're not going to touch on that today at all. But I'm just saying, like, what we're going through, like in Flutter at least, different layers, different type of memory leaks, different type of leaks in different layers. But we're going to touch on the very first part. Can someone tell me a difference between memory leak and memory bloating? Anyone knows? Any guess?
Memory leak is continuous.
Memory leak is continuous, that is correct, but memory bloating essentially means when you are excessively accessing memory for some reason. For example, let's say you're loading an image into a memory because you want to cache it and you want to reuse it, and you keep it there for your reference, so that still stays there forever, right? So that means you're excessively accessing memory without freeing that up. That's up to you for sure, and that's very deliberate. The problem with that is, so you're going to excessively always have access to the memory. So we know that. It may not necessarily lead to a crash in your app because it's under your control somehow. But the memory leak, as you said, is a continuous or increasement of the memory. And essentially, at some point, then you're going to run out of the memory and boom, your app is crashing. So the main difference here, we're going to talk about the second one, the leaking part. Where and how this is happening and why this is happening, even though Dart is a garbage collected language. It should not. It should actually free up memory for us. But still, it may happen. So this is a very high-level chart on how Dart garbage collection works. Essentially, Dart garbage collection is a generational garbage collection, which has two memory space, as we call it, young space or new generation, young space, and old generation. What it means, I'm going to simplify it for you. When an object is coming to the GC, so what happens is that most of the objects are collected as soon as possible, which goes to that nursery, the first phase. And if still the object needs to survive that first phase, the nursery phase, it goes to the old generation, stays there. And essentially an algorithm like mark and sweep happens, which checks for the reference of the object. And if the reference still exists, then it's marked, it stays there. And if it's actually not any reference for the object, it will get garbage collected. I'm going to look into it, like zoom in a bit, if this is still not quite understandable. Let's go a little bit deeper. When you're creating an object, yes, started the question right away.
There's some music.
There is some music. Is there any rock music? I'm hearing the music as well, I agree. It's not me though. There you go. Garbage collected. Exactly. Okay, thank you. So essentially, every object that we created, it lives in something we call it heap or memory. Okay. So what happens then? Dart keeps track of these objects and will reach them out by a reference. There is actually going to be a root object every time you create something. All right. What happens then afterwards if there is no reference? So garbage collector is going to check for the reference. Every time I do this, you hear me louder. Every time I do this, I think this is a very... let me just fix this, sorry, because it might be very annoying. Oh. I'm very sorry. Okay, that might be better right now. Okay. So the garbage collector is going to check for reference. Listen, reference, I'm mentioning this 100 times today because this is super important. You need to understand how you're creating these references are created, because that's the root cause of the way that garbage collector cannot or can garbage collected an object. So then it checks for the reference. If, then in this case, reference cannot be found, then it goes to the garbage collector and process, and the object it gets garbage collected. All right? But if it is still a reference somehow, even though you're not using that object anymore, listen, you're not using that, but there is a reference. Somehow you manage to create an object that keeps the reference still somewhere in the memory. Then it remains or retains essentially in the memory. That's where the memory leak is happening. And the main problem happens with the type of object where you have, where you have the objects that they are a type of object that we call them memory risky. But let me show you before that. Here is the root. Here is a very simplified version of how really these references get garbage collected. If there is an object with a reference somehow, so it will retain or remain in the memory. And this is like exactly the yellow one is an example of that reference object that is still existing. And those two blue ones, which they don't yet have any reference, they will be garbage collected. All right? So if you really want to learn a bit more in details, breaking down every steps with a sample code, so Anna, another GDE, so she has a very detailed talk from Flutter Vikings 2-3 years ago. So here's the video, I put it here. If you really want to learn deep dive into the Dart VM and how garbage collection works, how the algorithm mark and sweep works, and so on, please take a look at this one, this video. But so far, what we've seen is that, okay, the Dart VM, the garbage collector, is going to collect some of the objects that is not referenced. Perfect, we're happy, all good. By the way, this is GPT generated, super nice. But what is the problem here? The problem is, as I mentioned, those objects that are, as we call them, memory risky object. Essentially, the objects that you think they are going to be automatically garbage collected, but they will not. That is your responsibility to explicitly dispose them, cancel them, remove them. There are such an object, and we're going to go through them right now. So disposable object, I guess they're very, very familiar to you. Can someone, Flutter developer, give me a disposable object in Flutter?
Text editing controller.
Exactly, controllers. Those are the type of object that you need to explicitly in dispose call the dispose method. Otherwise, they will not get garbage collected. We're going to go through that right now. Look at this code. It's just 5 lines of code. And someone tell me what's wrong with this code. Wait a second. Give some people time. Have you written this code before? Have you written Flutter code before? This is a navigator. Come on. Anyone sees any problem here? It's in the build method. It's supposed to be in build method because I'm using the button and I'm passing a handler. But the problem actually, the problem resides in the service. I can give you a hint. Yeah, this could, well, you're right. In the build method, this can be run multiple times, but it's okay because at the end of the day, it's just a callback and I register it and it's just a button. So it doesn't matter, that one. The problem is, I can explain. You can say, you actually raise your hand.
I think since there's a register handler method, I guess there should be an unregister method as well.
Yes and no. You're referring to an interesting point here, which is actually register handler. What happens is that you are registering a callback, right? And then in this callback, you have a context, the build context object from Flutter, which is supposed to be a short-lived object. Then you're passing that to a service somewhere else outside of the life cycle of the widget. Now you see what happens. You're passing a short-lived object within a callback to another service outside of the life cycle, which is going to reside there forever. It's not going to be garbage collected. It's supposed to be garbage collected, but by doing this simple line of code that we all are doing, we're just adding extra memory effort, and the garbage collector will not take care of this part. Clear? Let's now go through it. So another example is this one. I bet you already use theme of context. Familiar, right? Then you're registering a callback and you are passing, again, the context. The theme of context is supposed to be short-lived. When you pass that to a callback and then pass it to a register handler in another service, so you're passing the short-lived object to another object that it will remain there because there will be a reference to this. It's supposed to be garbage collected, but you are making a reference somewhere else that it stays forever. Right? How can you fix this? I mean, this is a simplified diagram. If you really want to understand how it works, is that we have a widget, we have a life cycle. We're going to have the build, dispose, and initializing our state, and so on and so forth. But by just doing this simple problem, you passing the context, build context. Can anyone tell me actually what build context does in Flutter?
Element.
What does it do? Aiming? Element tree. You're just referring to one part of it, yes? Yes, go. Anyone? Build context is the most important concept in Flutter, and every single of you should explain it right now. Oh, don't worry if you don't know. No stress. Tell me.
So every widget has its pair element, and it presents the position of the widget in the widget tree, so we can access the
Exactly. Good explanation. Yes. You want to say something?
I wanted to say the same kind of thing.
Yes, that's good. So essentially, it actually holds a lot of information about the widget tree, and you get access to that. But when you pass this context, you actually keeping this reference with the object that you are passing by, and it will stay, like it keeps all of this information by itself. That's why gradually, by doing this, you're adding more and more and more allocation of the memory to something that is supposed to be garbage collected or disposed as soon as a widget is disposed. But you're not doing that. So that's going to be the problem, right? So, and this is an example of an app that I was profiling, Flutter DevTools. Hopefully all of you know what it is, and you are using profiling for memory. If you run that and you have a memory, you will see like suddenly when you're profiling, everything it goes fine. Then suddenly there is like a sudden increasement in the memory. You see it goes a little bit higher. You see it's flat. And then as you continue working with the application, go to the different widget, come back, screen, come back, go, and suddenly you see that memory is going higher and higher and higher and higher until, boom, at some point, it goes away. So use these actually tools. I will mention that at the end of the talk as well, effectively. The only thing you can do here to make it super more simpler for garbage collector to collect this short-lived object is that you reference the short-lived object right in the context of the widget lifecycle. Don't pass it to a callback, because the callback is gonna get the reference to that object forever, and the garbage collector will not be able to reach that to garbage collected. That's one thing you can do. And then another one is, well, it isn't just one example, and let's now go through these type of memory risky object that we're saying. Another thing is objects like global states, global variables that you define, the caching, for example, static methods like this one. These are also a type of object that usually are prevented from being garbage collected. And so it's your responsibility to make sure you clean them up. Well, let's see how. For example, this one, very similar, simple scenario for creating a cache mechanism, right, that you usually do in your application. So just allocating a limited size for the cache to make sure that you're not passing that excessive size of the memory, so the cache, sorry, it helps to prevent going higher than what it needs to go, even though you forget to clean it up. That's one example, or one tip here. Another thing you can do, have you heard about weak reference before? The weak reference is essentially help you to create an object without preventing it from being garbage collected. So when you create an object, let's say whatever object I create without weak reference, it has a strong reference. So then the garbage collector will always double check for the references, and if it cannot get access reachable objects, if it cannot be reached, then it cannot be garbage collected. But then if you have the weak reference and you wrap your widget with the weak reference, what it happens is that the garbage collector will always garbage collect it if necessary at any time. The problem with that is then you always need to double check whether the object still exists or not, or is garbage collected. The target on this widget, on this object is showing you whether it's garbage collected or not. If the target is null, that means it's garbage collected. You need to instantiate it, for example, again. That's the downside, but the good side, it's helping the garbage collector to collect the object. Where it's useful? When you are building caches, using algorithm like memoizing. That's a very hard word to say. Memoization. I'm just joking. So, but caching mechanism, so this is going to help you a lot. So another example for this would be, for example, when you are creating just a very high-level example of creating a cache for your images. If you are doing such a things right now, the image is just an example. It could be much bigger object. It could be anything else. It could be whatever, parsing a JSON or whatever. In this case, you can actually holding your data into a weak reference, so that make sure garbage collector is always collecting at the right time without preventing by any reference if it's not there or reachable. Another one is weak map. So this is going to help you create, you're using map for creating like key kind of value storage. This is quite normal. As a developer, we're doing that all the time. So if you are creating a weak map, essentially what happens is that keys are held weakly. This one, expensive object that I'm showing you right now in this code, in this example. It means that if you are actually going to, let me just go to the next one. Oh no, sorry, not next. I thought I have another line, but if you look at if we are going to remove the object one that we are instantiated here, which I did here, down there, if you look at it in object one, which I make it in equal to null. So in this case, So the keys are also going to be garbage collected without being prevented by anything else. So helps you to create essentially storage that can be garbage collected at any time by the VM. Very good for having like temporary kind of states, or you're building kind of temporary caching mechanism and you have very expensive objects to as the keys, for example. Another one is finalizer. A finalizer, is this familiar to anyone? Have you used it before? Okay, let's talk about it. A finalizer essentially is helping you to register a callback to get access to things to free up the memory for after an object is disposed or garbage collected. So what really is, why this is helpful? Imagine you have a plugin and that has access to a native memory. And now you're removing the object from Dart layer without yet freeing up memory in the native code. This essentially helps you, even the Dart object is removed from the memory, the callback to free up the memory in the native code still gets called, and that helps to free up the memory. So let's see an example here. This is just a workflow of how Finalizer works. A very high level, it just after you create an object, you actually register a callback. So in this callback, you register everything that needs to be called for free up the memory for the native code or anything else that I'll show you some example for. And essentially, this cleanup callback will get invoked after an object is garbage collected. Without the object still is being alive. Just look at the flow. So here is an example. A lot of you are using plugins or are somehow need to kind of write a plugin to get access to native code. So it's very common, like if you're using FFI or similar things. What happens is that in this point, to free up the memory in the allocated memory in the native code, which you see here, so you see that I'm just calling malcox, just removing the allocated memory from the native code. And the only thing I do then is I make sure that when this plugin is registered, I attach my finalizer that I've defined. And when that object is supposed to be disposed, and in the dispose method, I manually detach it. When I call this, then it immediately invoke the free up the native code in this case. So you're making sure it's not just removing this object from the memory, but also freeing up the memory from the native code. Clear? Sounds good. Lots of nods. Another example would be so like having a database and you open up the connection and your object is somehow at some point is disposed, but you still want to dispose or clean up the connection to the database. You can create such a callback, make sure that even it does not have access yet because the memory in the in the Dart code, the object is removed. It's not live anymore. So then you can still call something to free up, remove the connection from the database. One of the type of memory risky objects are in fact futures and streams. Let's talk about the streams. We use streams in Flutter heavily, all of us. Almost everything is kind of streams in one way or another. Like we're doing a lot of streams. So that's a very good thing we do. But the problem is when you're creating a stream, some sort of stream, and you listen to that, if you don't assign it to a variable, and if you don't remove that variable or explicitly remove the listener, then you are in a problem. You are leaking the memory in this case. So we're quite common do that. So we have a remove listener, for example, or we're disposing in a disposed life cycle of a widget. That's quite common. All of us, we're doing that. But it's more than this that we need to do. Let's talk about it. For example, so a lot of us are using future, right? And this is one of the things you can do so that you can cancel an operation from a future. But that does not mean the context or the callback that in that future, after canceling the operation, still is running. That doesn't mean it's not running. So therefore, it's your responsibility to make sure if the future is canceled, somehow the cancelable, you still check for the flag and make sure the code does not go and be executed afterwards. It's your responsibility to do such things, and make sure you assign this also into a variable and call the variable into the dispose life cycle, remove the entire cancelable object as well. Here is an example in adding a listener in initial init state life cycle. We start with this. We're adding a listener here in this case. These are like type of listener that I have not yet assigned any variable to. So that essentially means you are listening to something forever, even though the widget is disposed after you are getting away from a screen. So another, what you can do here, as I said, explicitly call, assign a variable, explicitly make sure you're disposing or canceling that object in the dispose method. So another thing is actually using the update widget lifecycle. I bet you're using this for doing different things. It's quite familiar, probably for most of you. So when you are assigning a listener, in a did object, update widgets, you need to make sure before you reassign or add another listener to this object, you need to make sure you're removing the previous one. Otherwise, you keep adding listener to that particular object or streams that you have. So make sure you're removing and then do the add listener again. So let's talk about a little bit of optimization. This might not be a very common scenario for you, like to create this type of code, but it's quite common to actually do one part of it, which is the last 4 lines. When I say buffer equal to buffer plus chunk, I'm concatenating multiple things into one buffer, even though I also have a shorthand plus equal, which is still like somehow a syntactic sugar. What happens here is that every time, anyone can tell me what's actually the problem here. Let's test your knowledge. It's a very simple concatenation. We're just saying buffer plus chunk equal buffer. Shall I say? Anyone can say? Every time you say buffer equal to buffer plus chunk in this loop, it actually creates a new list every time you do that. And that adds up to the allocating the memory every time you're doing that. This is like 100, this is a small loop right now, but if you have a bigger loop, that's going to be a big problem. So I'm going to show you like how you really can fix this. This is essentially, if you talk about the the O time, it's actually ON2. It's like quite steep in terms of usage of memory. So, but what you can do is you make sure at least, I'm not saying you should, like for simple things, you really go and make things complicated, but make sure you understand that there are different ways to do one things and why they exist. Like here in this case, if you repeat the same thing in 4 different ways, with a spread operator, with concatenation that I showed you, add all, and byte builder, they are going to do the same things, but significantly different. Like the byte builder example I will show you here right now, the exact same example that I've done to create that list, I do with the byte builder, and that's going to be way faster and less memory allocation. These type of optimization are quite useful for your applications. Another thing is the const constructor. I bet all of you know this one, of course. This is quite common in Flutter that we put, as much as possible, we create const constructor. There is a reason to do that. What happens is that when we are creating a const constructor, very simplified version of this, let's not go through the how Dart really works behind the scenes to do this, but a very simple thing is that when you do this, in fact, you are creating the same object. You see that I actually instantiated 2 instances of the object there, the person object, similar one. And if you look at with identical, you see both of them are actually equal. That means you are sharing even, they are using the same even memory. So in terms of optimization memory, it's even using the same memory. So this is quite helpful in this case. Like if you, why this is helpful for the widgets? You're creating a widget identical 1,000 times, let's say, in one page, right? Because you have a list builder and you're just repeating that for 100 times with the same maybe value or different, doesn't matter. But the same value for the object, if it's repeated for the same widget, that means you're not allocating multiple memories to that object that is created. So it's one type of optimization, and it actually has other benefit as well. Like it becomes immutable. It becomes like quite optimized for the compile time and so on and so forth. So let's not go through that, but I just wanted to focus from the memory point of view, which is sharing the same pointer. So let's go through the next one. Let's talk about some of the features in Flutter that helps you to have optimization on allocation of the memory. For example, using the list.view.builder, which is going to lazily create the objects in the builders. This is going to help you to reduce the footprint of that creation in the widgets. I have 2 minutes, right? Still. So organizers. Yes, sounds good. So I'm going to just quickly give you a few more points on this. For example, in a list view builder, you can even do different things. For example, you can assign as much as, this is a rule of thumb in Flutter, as much as possible, create const constructors. So as much as possible. So then here is also an example here. I have the icon, which is going to be similar, and if it's not dependent on the index in this case, I'm going to go and assign it to a const. Then I can also go and assign the add automatic keep alive to files, which is going to make sure to reduce the memory when, essentially, if this is true, this widget is going to be wrapped by keeping alive, so that it always alive in the memory. But if you make it disable, then it will reduce the persistence of the state. So it depends on, of course, your use case. You might need to have the state. You need to persist it. But if you don't, and it doesn't matter, make sure you explicitly call that to false. And then also adding a cache extent, which controls how aggressively, let's say, Flutter pre-builds the item. So in this case, also helps you for a smoother scroll and so on and so forth. And also less, not necessarily a less memory, but at least optimization on the scrolling. So a quick, give me 1 minute, a couple of slides to quickly wrap up. First thing first, as much as possible, bring these detections to the left, as we call it in software engineering, shifting left. So the more you actually detect these type of things in the development when you are working, this is gonna reduce the cost of shipping buggy application to the product. The more you do this or like happens in production, the costlier it becomes, both for customers and you. There are different tools now from Flutter team, some of them experimental, some of them are right now stable. You can go ahead and use. Leak Tracker is one of those. We don't really go through the tools. I'm just going to introduce it to you. I think by now you understood a bunch of ways that you can optimize your code for memory. So these are essentially going to help what I said to detect your memory issues during the unit testing. Here is an example for the leak tracker. Very simple. You can actually start your widget if you want to detect something and then track the memory issue and gives you a report, or use the experimental leak testing package, which is going to just enabling the memory leak tracking in the unit testing. So super useful because we all write unit tests, right? How many of you write unit tests? If you're writing unit tests, it's going to be helpful. If you're not writing unit tests, please write tests. So, and just an example of auto snapshotting. This is a package from Flutter team. I just recorded this simple video. So you can run the application. If the package is running, then you can actually, it is automatically detecting, giving you a snapshot. You can use this snapshot then afterward in Flutter tools, Flutter Dev tools, and then take a look which object is actually or is really like taking more than enough allocation of the memory. You can detect it. So this is an interesting and helpful tools, I guess, if you find such a problem in your application. Please get familiar with profiling and memory tab in DevTools. There's a lot of details in this the DevTools for profiling the memory, understanding when is going to be VM garbage collected, when is like you manually helped it, when is blah, 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 blah. So understanding all of these points just helps you to get a better understanding of your application when the leak is happening. And we had a very long session yesterday about DCM. Of course, you can use tools. DCM is one example that helps you to many of the things that I mentioned about assigning, like for example, listeners or removing listeners, disposing, or these type of things. These are easily can be prevented by lint rules, which are available, for example, in tools like DCM. So you can just go ahead and run or add these rules and make sure you're not really missing out these type of optimization. So the tool is automatically, the analyzer is going to help you automatically to detect that. That was all of my slides. So obviously, if you want my book, I have to promote it. So this is the discount code as well, 70%. This is digital version if you want the book. And I'm going to go to the last slide in a second. If you want the slides as well, in the next one, you get the slides, you get all the sample codes. References existed in the slides. I think I put some notes also for you to just, if you forget what I said, because I talked 50 minutes right now, it's a lot of talking, you can just look at the notes and also keep track of what I said. Make sure we're connected. We're going to talk after this talk as well. And I'm going to be around for questions. I think I'm way over time right now.
Well, yeah, let's pick up one or two questions, maybe.
Let's pick up one
Okay.
of two questions.
So if you have any question, raise your hand.
Yes.
About like, sorry, thank you for the presentation. It was like really nice, and it's going inside the memory leaks. Yeah. So about the first one, we said like we have a listener. Not listener, like we are passing a context to the service. Yeah, but will it help like if we just dispose that service in the same widget?
Yes, the thing here is that it's not about passing the context to the service. It was actually about passing a context to a callback and pass the callback to the service. That callback will cut the reference check into the service that you're passing. If you pass the context to the service itself, that's going to be okay.
Okay, you mean like the callback will stuck in the stack?
Yes, my main point there was you need to assign that context to a variable in a widget lifecycle first that can be tracked, and then pass that if you want to do that. Obviously, my recommendation is never pass context to anything like a service. You should not do that. If you are doing this right now, you are doing it wrong. I'm saying that strongly, you're doing it wrong. The context is supposed to stay in the widget. You need to make your architecture in a way that services are not dependent on the context. If you're doing that, you need to change your architecture.
Thank you.
Maybe one more, if you have any.
Yes.
Thank you for super useful presentation. Could you show me buffer builder slide?
Which one?
Buffer builder, builder buffer.
Byte builder.
Byte builder.
That's for
Sorry.
creating the string. Yes, I can show you. If you want to create a string, you can, yes, I think this is it.
Previous one, sorry.
Like this one?
More, yeah, this one.
Yes.
Let me confirm my understanding.
Yes, yes.
You
please.
mean I shouldn't declare a local variable like chunk and int chunk? I shouldn't declare the local variable in for loop?
No, I didn't say that. So I said what happens here, if buffer equal to buffer, what you do in this line, so for those you're seeing from the other side in this line, and this line and this line, what you do here, every time you say buffer plus chunk equal buffer, you create a new list here. And in an array, that means every time you have an array, you create another list, and then another list, and this is a loop that happens. And that increases the usage of the memory. That's what I said. But I'm not saying you should not do that. This is one way of course, concatenation. And maybe in this simple example, this is absolutely fine. It's not even, it's a super fast operation. This is a simplification of what I said about creating an array here in this case. So I want you to understand when you concatenate two things with plus, what happens. That is important. That creates a new one. And then when you have this array, a new array, then it loops, and then essentially the O, the big O, if you know what it is, it becomes N2, and it's like the memory usage is high.
All right, I got it. Thanks.
So thank you, Majid. So
welcome.
let's give applause to him. So for more discussion or questions, feel free to visit Ask a Speaker corner.
Yes.
And we'll now take a break. The next session is starting at 11:25. Thank you.